Hello folks, and welcome back to another lesson. Today we're going to be covering section 6.5, and what this entails is solving radical equations. Now to get us to start thinking, we're going to do an absolute value equation problem here. Our radicals will act very similar to absolute value equations, and we'll be dealing with some absolute values a little bit later in the lesson. So to start off, how do we solve 2 times the absolute value of x plus 1 plus 3 is equal to 13? Well, our first step is to get the absolute value entirely by itself. So subtract the 3, divide by the 2. What you end up with is the absolute value of x plus 1 is equal to 13 divided by 13 minus 3 will give us 10 divided by 2 will get us to 5. So first step, get the absolute value all by itself. But then after that, what we want to do is we want to split this up. We say x plus 1 can be either equal to the positive version of this value. Remember, an absolute value is just a distance. So what values are a distance of 5 away from 0? Positive 5 and negative 5. So split this up and then solve. We would find our answers are x is equal to 4 and x is equal to negative 6. So that's absolute values, but today we're talking radical equations. So let's go over what does and doesn't define a radical equation. Here we have a couple of examples of some radical equations and a couple of examples of things that are not radical equations. On the left-hand side, the one with the radical equations, we have variables inside of the roots, right? 3 square root of x plus 1. Or if we're doing this as a fractional exponent, we have x plus 3 to the 1/4. However, in these ones that aren't radical equations, we see that we have square roots and we have fractional powers. They're just not dealing with our variables. So our variables being part of the radical is what makes this a radical equation. The definition we'll be going with for a radical equation is an equation where the variable is inside of a radical or rational exponent. So it's an equation where the variable is inside the radical or rational exponent. So keep that in mind. If your variable is inside of a square root instead of a cubed root or inside of a fractional exponent, that's when we will be using this. Now let's go ahead and try to solve this problem. You'll see it's very similar to the absolute value problem we have, 2 square root of x plus 1 plus 3. And we're going to follow the same rules for this. We're going to start by trying to get the square root by itself. Right? Subtract 3, divide by 2, and we're left with the square root of x plus 1 is equal to 5. Now how do we get rid of the square root here? To get rid of a square root, the opposite is a square. Right? This makes sense because we could rewrite this as x plus 1 to the 1/2 is equal to 5. So to get rid of this 1/2 power, what would we have to do? We'd have to raise everything to the second power. Or in other words, we're going to square both sides of this equation. That'll leave us with x plus 1, right? The 1/2 and the second power cancel, will be equal to 25. Or our answer is that x will be equal to 24. Now when we're dealing with square roots in our radical equations, we don't have to worry about plus or minuses. When we're taking the square root, we do, but because this is just the positive square root, it's already implied. If we wanted both the positive and the negative, we would have to say that this is the plus and minus equation. Okay, so solving radical equations, pretty simple. All you do is you get the radical by itself, you then square, or you get rid of the radical by using that power, and then you finish solving for whatever's inside. The one thing we have to be careful of, though, is what we call extraneous solutions. An old friend coming back to greet us, Extraneous solutions are solutions that appear when we solve the problem, but don't work when we substitute them back in. Or in other words, they're false solutions we get out of the equation. So to write out this definition, we're going to call an extraneous solution a solution that doesn't work when subbed back into the equation. So when it's substituted into the equation. This means that to look for extraneous solutions, we have to substitute our values back in to check whether they make our equation true or false. Let's go ahead and try a problem that might have an extraneous solution. For this one, we're looking at the square root of x plus 7 minus 5 is equal to x. Now don't be worried about the x being on this side. We're still going to take the same steps. We're going to move the minus 5 over, and this equation becomes x plus 7 is equal to x plus 5. Now we still need to get rid of this square root. We can't deal with an x inside of a square root. It will make it impossible to solve. So we're going to have to square both sides of this equation. When we do that, we'll end up with an x plus 7 on the left-hand side. Our square root and our square will cancel out. And then on the right-hand side, we'll have x plus 5 squared. How do we solve that? Well, we'll have to expand it, right? It's x plus 5 times x plus 5. Or when we solve this, we'll get x plus 7 is equal to x squared plus 10x plus 25. And then we'll bring all of our x values over because now we're trying to solve a quadratic. So all we're going to do is we're going to bring our x values over and factor to see what our solution will become. When we do that, we'll get 0 is equal to x squared plus 9x plus 16 plus 18, and then we'll just factor this. When we factor this, we'll see that our solutions will be 0 is equal to x plus 6 times x plus 3. Right? In other words, we're just looking for factors of 18. We can use a shorthand. We can skip this. Or our possible solutions are x is equal to negative 6 and x is equal to negative 3. Now here comes the tricky part of this problem. Now we have to check this for extraneous solutions. So anytime we're dealing with square roots or radicals, we need to substitute our values that we found for our answers back in to see whether they are proper solutions. We're going to substitute both negative 6 and negative 3 back into the original equation to see whether they turn out true or not. So let's try that. We're going to test out the point negative 6. When we do that, we get the square root of negative 6 plus 1, or plus 7, minus 5 is equal to negative 6. Okay. When we simplify this, we get the square root of 1 minus 5 is equal to negative 6. And 1 minus 5, right, we're only dealing with the positive root here. We don't have a negative. So this is just plus. It's plus 1, not minus 1. That says 1 minus 5 is equal to 6. Now this is very much not true. That would be negative 4 and not negative 6. So that's not true. That means that negative 6 is an extraneous solution. It means that we cancel this out, and the only solution we could possibly have left is x is equal to negative 3. Of course, we're going to need to check this one as well. So we say negative 3. We try to substitute this in. We say the square root of negative 3 plus 7 minus 5 is equal to negative 3. Or that's the square root of 4 minus 5 is equal to negative 3. And because we're dealing with just the positive value, that's the same thing as saying this is 2 minus 5 is equal to negative 3, which is true. So negative 3 is not an extraneous solution. The only extraneous solution is negative 6. And our answers are, or the solutions are, just x is equal to negative 3. Right, now we have a couple of problems for you all to try here. We're going to have you do both of these. Go ahead and start with this first one. What's our solution for 3 square root of 2x minus 3 plus 5 is equal to 17? Our first step here is going to be isolate the square root of 2x minus 3. So we're going to subtract 5 and divide by 3. When we do that, we'll end up with 2x minus 3 is equal to, see, 17 minus 5 gives us 12, divided by 3 is 4. Now we have a square root by itself. To get rid of that square root, we're going to square both sides. When we square both sides, we end up with 2x minus 3 is equal to 16. And then we just keep solving. Add 3, divide by 2. That'll tell us that x is equal to 19 divided by 2. Or if you put this as a fraction, that should be 9.5. Decimal, excuse me. Now let's double check, make sure that this isn't an extraneous solution. So when we check this, we say 3 times the square root of 2 times 19 over 2 minus 3 plus 15, or plus 5, is equal to 17. Now we have a 2 times a 19 over 2, meaning that that just becomes 19. Or when we check this, we get 3 times 19 minus 3 is 16, plus 5 equals 17. We can keep checking, but 3 times 4 plus 5 does equal 17. So our answer is correct. Okay, now try problem 2 here. What's the square root of 5x minus 1 plus 3 is equal to x? What are our solutions for x? Make sure you check for extraneous solutions as well. Now when we solve, the first step we need to do is isolate the square root. So when we do, that leaves us with the square root of 5x minus 1 is equal to x minus 3. And now to get rid of that square root, we're going to square both sides. Squaring a square root will cancel those out, so we have 5x minus 1. And then we have x minus 3 squared here, so we're going to expand that. That should become x squared minus 6x plus 9. Now, because this is a quadratic now, we're going to get everything to one side and try to factor. Where this becomes 0 is equal to x squared minus 11x plus 10. Or that's x minus 1, x minus 10. So the solutions we expect are x is equal to 1 and 10. But we need to check both 1 and 10 to see whether either of those are extraneous solutions. So when we test 1, we're going to see that this is the square root of 5 minus 1 plus 3 is equal to 1. So the square root of 5 minus 1 will give us the square root of 4 plus 3 is equal to 1. Now again, be very careful here. This isn't a plus or negative square root. It's just a positive square root. So that means our solution here is 2 plus 3, and 2 plus 3 is not going to be equal to 1. So 1 is an extraneous solution. That's not going to be an answer. Let's check 10. When we substitute in 10, what do we get? So we have the square root of 50 minus 1 plus 3 is equal to 10. Or the square root of 49 plus 3 is equal to 10. Square root of 49 is 7, so this is still true, meaning that 1 was an extraneous solution, 10 was not, and our solution here is 10. Now there's one more important thing to note when we're doing these, which is sometimes these can appear as fractional exponents, right? Radicals and fractional exponents we've determined are the same. If you have some value raised to a fractional exponent and you're trying to solve for x, then we have to use the absolute value of x when we're solving. So we need to use the absolute value of x when solving. This goes back to squaring values because, or anytime we have an even value, because we can have the positive or negative versions. So anytime we're dealing with an even denominator or numerator in our power, make sure that the interior part becomes an absolute value after you solve. Okay, let's give this a practice run. That way you can understand what I'm talking about. We're solving 3 times the cubed root of x plus 1 squared is equal to 12. Our first step here is going to be divide by 3. So this is the same thing as the cubed root of x plus 1 squared is equal to 4. Now that we have this, we can rewrite x plus 1 squared cubed root as x plus 1 to the 2/3 power is equal to 4. Now, how do we get rid of a 2/3 power? Well, we want to raise this all so that our power is going to be 1. To get that, we're going to need to multiply by the reciprocal power, or raise to the reciprocal power. So we're going to raise to reciprocal power. Reciprocal power, meaning we flip our fraction. X plus 1 to the 2/3, we're going to raise this all to the 3/2 power. And 4 we're also going to raise to the 3/2 power. So we have a 2/3 to the 3/2 power. We multiply those together, that'll cancel out. We'll be left with, and here's the tricky part, the absolute value of x plus 1. We have the absolute value because we had an even power. We had a 2 as one of our values. And then we have to figure out what 4 to the 3/2 power is. Now you could throw this into your calculator, or we could do this by hand. Right? 4 to the 3/2, that's saying the square root of 4 cubed. Square root of 4 is 2, and 4 cubed will give us 8. Otherwise, if you're not comfortable with this, you can just do it in your calculator. So here we have the absolute value of x plus 1 is equal to 8. We're going to need to split this twice, because what values are a distance of 8 away from 0? It's positive 8, and it's negative 8. Meaning that our two possible solutions are 7 and negative 9. But wait, there's more. We're not done just because we've reached these two values. We have to check for extraneous solutions. Meaning we're going to substitute in 7 into this equation and see whether it makes sense, and we'll substitute 9 in and see whether it makes sense. So let's go ahead and do this. When we do, we get 3 times the cubed root of 7 plus 1 squared is equal to 12. Or 3 times the cubed root of 8 squared, 64, is equal to 12. Now what value cubed gets us to 64? Well, 4 cubed is 4 times 4 is 16, times 4 gives us 64. So 3 times 4 does equal 12. That means 7 is a solution. Now let's test out not 9, but negative 9 here. When we substitute negative 9 in, we're going to get 3 times the cubed root of negative 9 plus 1 all squared equaling 12. So this is going to be 3 times the cubed root of negative 9 plus 1 is going to be negative 8. Squared is going to be 64. Negative 8 times negative 8 gives us positive 64. And we end up with the same thing. We get 3 times the cubed root of 64, or 3 times 4 is equal to 12. So both our solutions are correct for this. Neither of them are extraneous. Our two answers are x is equal to 7 and x is equal to negative 9. Now let's have you all try a couple. First one we have here, we have 2 times x plus 1 to the 2/3 power is equal to 8. What would our solutions be for this? To start off, we need to get this fractional power by itself, so we're going to divide by 2. We get x plus 1 to the 2/3 is equal to 4. Again, we're going to raise this to the 3/2 power to get rid of our exponent. We have 2/3, so we need to multiply by the reciprocal. When we do that, we're left with the absolute value of x plus 1. So we get the absolute value of x plus 1, right? We have an even power. And 4 to the 3/2, we just saw in the last problem, that's going to be 2 cubed, or 8. So we split this up. We say x plus 1 is equal to either positive 8 or negative 8. And then we solve. We say x can be either equal to 7 or negative 9. Now when we do this, we have to test to make sure that it still comes out true. So if we substitute in 7, we see that we have 2 times 7 plus 1, or 8 to the 2/3 power, is equal to 8. When we do this, we substitute, we say the cubed root of 8 is 2, squared is 4. So this is 2 times 4 is equal to 8. So that works. With negative 9, we test again. We say, okay, this is 2 times negative 8 to the 2/3. And negative 8 squared is still going to come out to be positive. So this will also come out to be 2 times 4, meaning that both of our answers are correct. Right. We have one more for you to do here. We have 3 times the square root of x plus 1 cubed minus 2 is equal to 25. Now let's move on to the next one. We have the square root of x plus 1 cubed minus 2 is equal to 25. What are our solutions going to be? When we do this, we're going to need to pull the 2 over, and let's convert the x plus 1 into a fractional exponent. So this becomes x plus 1 to the 3/2 is equal to 27. Now to get rid of this, we're going to multiply or raise to the 2/3 power on both sides. 2/3 power. When we do that, it'll cancel out on the left-hand side. Because we had an even part of our power, it's x plus 1 is equal to, now the cubed root of 27 is 3, or when we put this into our calculator, we'll see that this is 3 squared, or 9. Meaning that our solutions are going to be x plus 1 is equal to positive 9 or negative 9. And the values we have to check are 8 and negative 10. So let's go ahead and check those values. When we substitute in 8, we're going to see that we're looking at the square root of 8 plus 1, or 9, cubed minus 2 is equaling 25. So what's the square root of 9 cubed? You just throw that into your calculator to find out. You'll get that the square root of 9 cubed is 27, or 27 minus 2 is 25. So we're good with 8. Now let's try negative 10. When we do this, we're going to get the square root of negative 10 plus 1 cubed minus 2 is equal to 25. Or in other words, this is going to be the square root of negative 9 cubed. Negative 9 cubed is going to give us a negative value here. Negative 9 cubed will give us negative 729 minus 2. We can't take the square root of a negative number. So that means that negative 10 is not our solution. Our only solution for this one is x is equal to 8. Right. Now we have a couple more application problems if you want to look. Slightly more challenging problem, but we're going to skip over that to give us the important points for this to remember. Let's see if you all can figure it out. After solving a radical equation, you must always check for what? You must always check for extraneous solutions. So you need to make sure none of your answers, when you substitute them back in, give you bogus answers. Now, if you're eliminating a fractional exponent and either the numerator and the denominator are even, you need to remember what? If either your numerator or denominator of your power are even, you need to remember your absolute value. And the last part, before eliminating a radical or fractional exponent, you must raise it to what? When you're doing these, if you have a 2/3 power, you raise it to the 3/2. You must raise your radical or your rational to the reciprocal power. And that, folks, is all there is to this lesson.